Hello, I'm Chris. This is Gross Models, and this is day 2 of the Inventor 30 Days Lost in Space Adventure Kit. This one is titled Day 2. It's really dark in here. This time we're going to be playing with a light. I know we got the light working yesterday on the board, but they're saying we need more light. So this is actually how to actually make proper lights work. So we're going to be playing with resistors and wires and the breadboard. I'll play the first intro bit from the site itself, and then get on with doing what he tells me to do.
Hi. Hello, incoming transmission from Adventure Corp. It seems as if you finally got your board blinking. Yes! Which means you got your first bit of code finally uploaded, which means you can get started with all the rest of the programs. Of course, that was probably the hardest part, and believe it or not, there's a lot of people that get tripped up on that. But luckily, now that you've progressed past that, we can start learning so much more about the rest of the parts that you'll be needing to fix your ship and the code and logic that goes along with it. In this video, I'm going to quickly show you guys, because it seems like your cabin is very dark. That's at least what our indicators are saying, is that it's not very bright in there, and you kind of just have the board LED on right now. So knowing that you can't see very much, I'm going to quickly send you guys this video on how to wire up an external LED through what is known as, if you see over here, the breadboard, and with resistors, wires, and of course an LED of your choice of color. It does not really matter which one you decide.
Right, he spends a little while talking about the breadboard and how it comes apart, and he takes it apart and shows all the bits in the back. It does actually connect up. This entire strip down the end there is one piece. The second piece is also one piece, and this is one going across, and the same going across the other side. They're separate. That half is separate. That half is separate. Basically, he shows us taking one apart and all that and everything else. Then he gets on with talking about the actual bit that's going to be important. We need a 220 ohm resistor, which I shall pop out the packaging here and get rid of that. That's all we need. 2 wires, an LED, and a resistor. I'll get through to the bit where he's telling us about what we're going to do, and we'll work along and do it with him.
Plug it in like so, and it doesn't really matter where exactly you put it on the board. There'll be a diagram below, but you'll see the longer wire is going to be towards the higher numbers on this case. For my
number's going that way.
I'm going to put that there, and I'm going to wire the ground, which will be the shorter one, into one of the grounds on the board. So I'm going to put right, if I can get this in correctly.
Yep.
And then you'll take the other wire here and put it into this side. Let's see. I'm going to use pin 12 for this. And the reason I'm choosing pin 12 is because you'll notice that on this side of the board you have all of the input-output pins, which is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and all, and etc. All along this line. It's also labeled on the board.
I'm going to use 12 as well, because
all the way to this side of the board yet. I'm going to wire it right before that on this side, and I'm going to connect the two with what is known as a resistor. Now this here is a 220 ohm resistor. The reason we're using a 220 ohm
it's gone higher than that. Let's go up there.
If you use a little bit of math and understand Ohm's law, you want a resistor that, well, let me first explain what a resistor does. That's a good thing to do.
All right. Resistors resist flow, so we know about that. I'm not going to bother showing you all of that.
Voltage, etc., that goes across a line.
Okay, so the wiring has been done. As you can see here, I've got going from a ground on the pin here through to the negative terminal of the LED. Pin number 12, which is just the one he said to use in the video. You could use any of these, I think. It doesn't make any difference. Going to somewhere else on the board, and then a resistor going between that and the positive leg of the LED. Then the interesting bit comes up in the corner there. I've typed in some things. Hopefully you can see it. I can't actually make the text any bigger on there. But the int line at the top is basically telling that the pin number 12 that I plugged that into, we're just going to call LED. It's just changing the name of it to make it easier to understand. And then in here we put pin mode LED output, saying that the pin 12, which we're now calling LED, is the output. Digital write is, we're now sending a thing to the LED and we're saying hi, which is putting it to 5 volts as it says in there. So if I now activate that, I plugged in the board and turned it on, that's why I've got the lights on. If I upload that to the thing, it's saying, do you want to save it? I don't really want to save it at the moment, but we'll worry about that. It's receiving information and the light has come on. So that's taught us a little bit about wiring, a little bit about coding and renaming things in the coding. Now the one thing that he also did on the video as well is put in a thing in the loop. Let's see if I can do it as well. What he's put in is digital write again, and he's put LED low. Then he put a comment saying that that was grounding it, which it is. Then he put in a delay, once again of a second. I'm going to put in half a second because I can. It's not going to work. I forgot to put a thing after that, didn't I? Let's put that back up there. Put a semicolon in, otherwise it would get confused. And then once again we did digital write again. Why is that not gone into a different colour? Let's worry about that in a minute. Also 500, no, not 500, that's not delaying. We're calling that LED, and we're putting that to low, that, and then semicolon. I didn't put a capital W, that might make a difference on this. Let's have a look. Yes, it needs, the capitalisation is important. Delay on there of again 500. So now when I upload this information to it, it should turn it on for 500 half a second, to turn it off for half a second, to turn it on again. So turn it on to begin with, then it'll turn it off, and then on. I'll put low again. Let's put high in there. Right, that should be it. Let me compile it to make sure it verifies and make sure it is actually correct. Nothing's complained at me. Then I shall send that off to it, and we'll see. Yep, we're getting half-second bleeps out of that. So, all in all, I'm happy with that. I've learnt that so far. I could have used a different colour LED. In fact, I will. I'm going to unplug the power so I can take the LED out without any problems. I'll put the yellow one in, getting the legs the right way round. Being a diode, it matters which way round the legs are. Plug that back in, and we get the yellow light, which doesn't look wildly different on that. The blue, green. I want the clear one. I want to see what colour the clear one is. There's only sent me one clear one. I'd like to know. Getting the legs, the longer leg is the positive, so we get that the right way around. Again, it doesn't matter which holes in that line I use, as long as it's the right way around. So that one, yes, is a bright white. A very, very bright white. So, yes, I'm happy. We've learnt stuff. As ever, I'll let him sign out and say goodbye. But I'm happy that I've learnt things.
And I think that just about gets you ready for whatever comes next. We'll be back to you tomorrow. Alex, over and out.
There we have it. Thank you for joining me. It's not actually on, that's just reflecting the light, that clear one. Thank you for joining me on day 2. I'll see you soon for day 3, when we'll be looking at other things. I haven't cheated and looked forward, so I don't know what's happening tomorrow. So I'll see you soon for that. Thanks for watching. Bye bye.